In this video, we are going to discuss about non-preemptive priority scheduling. Okay, so it is non-preemptive priority. What is meant by preemptive and non-preemptive? If a scheduling algorithm is called non-preemptive, that means that a process which will enter into CPU, then until and unless all the instructions of this process is executed, it will not leave the CPU. Okay, so what is meant by non-preemptive? Once it enters into CPU, it has to finish its execution and it will come out. Okay, until and unless all the instructions are executed, it will not come out. Now here we are going to discuss about priority scheduling. This is especially non-preemptive priority. Okay, so the criteria will be every process will have a priority. Okay, depends upon the process. We will categorize it into different priorities. So, sorry, we'll assign some priorities. Depends upon the category of process. We'll assign some priority. Okay, so here first one, at any point of time or any instance of time, a process which will have highest priority will be scheduled first to CPU. Okay, but there are certain cases the process P1 and process P2 may have same priority, that is 3 and 3. Okay, so then if both have same priority, then we will take minimum arrival time. That means if P1 arrives at time t equal to 4, P2 arrives at time t equal to 6, then P1 will be sent to CPU. Okay, so at sometimes there is one more cases where the process will have P1. Okay, okay, so P1 will have same priority 3, P2 will have priority 3. So the priority will be same, and even arrival times are same. Both are arrived at let us assume 0 and 0. Okay, both arrival times are same. Then we need to take the PID, lowest PID. So we need to consider minimum of their PID. So out of these two, the minimum will be P1. Okay, so minimum PID will be P1. P1 will be scheduled first. Okay, right? So this is our criteria. Let's start a question. Okay, so the question is given in the theoretical format. We need to convert it into table, but I'm directly writing the final table, not the conversion. Let's see here. Apply non-preemptive priority scheduling algorithm and find the average waiting time and average turnaround time. We need to find average waiting time and turnaround time. So all process arrived at in the order P1, P2, P3, P4, P5 and arrived at the same time. So we need to assume they are arrived at time t equal to 0. Okay. So the priority, a larger priority number implies a higher priority. So 2, 1, 4, 2, 3. So which one will have high priority? P3 will have high priority here. But now let's see the ready queue. Okay. In ready queue, all process are arrived at the same time. That is 0. So now we need to write in the order P1, P2, P3, P4, P5. They are arrived in order P1, P2, P3, P4, P5. Okay. Then we need to start loading the process into CPU. Okay, so first one, the priority, let's write the priorities here. What is the priority of P1? 2, and P2 1, P3 4, P2 sorry P4 2, P5 3. Out of these, which one is having highest priority? P3 is having highest priority. So at time t equal to 0, which one will be loaded into CPU first? P3. So this will be your Gantt chart. Okay. So 0, what is the burst time of P3? 8. So it will be executed up to 0 to 8. Okay. Then this one will be execution completed. At time t equal to 8, out of how many process remaining? P1, P2, P4, P5. So which one is having highest priority? P5. Okay, so P5 will be loaded. And what is the burst time of P5? 5. So 8 plus 5, 30. Okay, so P5 is also finishes the execution at time t equal to 30. Then after P5, how many are left? P1, P2, P4. Okay, 3 are left. So out of these 3, now look at here, P1 and P4 both are having priority 2. Okay, now if both are having same priority, we need to take the arrival times, minimum arrival times. But look at here, the arrival times are also same. If a process which will have both having same priority and both came at same time, the arrival time is also same, then we need to take their minimum process id. So which one will be scheduled? P1 will be scheduled. What is the burst time of P1? 2. So it will be execute up to 13 plus 2, 15. Then ultimately P1 execution completed at time t equal to 15. Then P4 will be there, it will be loaded at time t equal to 15. Then the burst time of P4 equal to 1, so it will be 16. Then at time t equal to 16, there is only one process left, that is P2. So P2 will be executed up, sorry, P4, this burst time is 4, so it is 15 plus 4, 19. Then P2 will be loaded, its burst time equal to 1, then 19 plus 1, 20. Okay, correct. Okay, now write the completion times of each process: 0, 8, 13, 15, 19, 20. Okay, so write down, you will get completion time. P1 finished at 15, P2 finished at 20, P3 finished at 8, P4 finished at 19, P5 finished at 30. Okay, now turnaround time, what is the formula for turnaround time? Completion time minus average arrival time. So it will be again 15, 20, 8, 19, 13. Okay, so then what is the waiting times? It will be 15 minus 2, 20 minus 1, 8 minus 8, 19 minus 4, 13 minus 5. So it will be 13, then followed by 19, 0, 15, 8. So if you calculate this one, 15, 28, 19, 13, so it will be 15 into, so divided by 5, you will get 75 divided by 5, so you'll get 15. Okay, it will be 75 divided by 5. Okay, similarly this will be 90, 0, 15, so it will be 55. So average will be 11. Okay, this is 75 by 5 and this is 55 by 5, correct? So 90, 13, 90, 32, 15. Okay, right. Okay, so next we'll see the different arrival times. That means the arrival times will be different, and this is one of the previous year questions that is came in your Usmania exams. Now let's see one more problem, same problem but arrival times are different. Okay, so I won't take much time. Let's convert this one into table and let's design Gantt chart. Okay, so here they are not arrived all arrived at same time. Okay, they are arrived at different time. Now first we need to take which process came at time t equal to 0. Now look at here, P1 comes at 1, P2 comes at 0, P3 comes at 3, P4 comes at 1, P5 comes at 2. Now let's see at time t equal to 0 how many process came. Only one process came at time t equal to 0, that is P2. Okay, now the CPU does not wait for more any more process to come. So at time t equal to 0 there is only one process, then that particular process has to schedule to CPU. So which process will enter regardless of priority or first come, what it doesn't matter, priority it doesn't matter, because this is the only process left. So even you take priority, the priority will be 1. Okay, and high priority will be 4 only. Now let's check the burst time of P2 equal to 1. It will execute up to 1. Now check. In 1, at the time P2 completes, now check here, you can see that at time t equal to 1, at time t equal to 1, how many process came to ready queue? P1 and P4. So write down P1 and P4. Now P2 is completed. Write down the priorities of P1 and P4. The priority of P1 equal to 2 and priority of P4 is also 2. Now let's see here. The priority of P1 and P4 equal to 2. Now if priorities are same, we need to check arrival times. But the arrival times are also same. Then we need to go for minimum process ID. So P1 is having burst time 2, so it will execute up to third second at time t equal to 3. Now during this execution of P1, that is 1 to 3, let's take how many process come to ready queue. There is at time t equal to 2, P5 came to ready queue. At time t equal to 3, P3 came to ready queue. P1 execution is completed. Now write down the priorities of P5. What is priority of P5? 3. What is priority of P3? 4. Now at time t equal to 3, all the process came to ready queue. The process that are left are P4, P5, P3. Okay. Out of these three, which one is having highest priority? Now compare here. Now compare here which one is having highest priority. P3 is having highest priority. So at time t equal to 3, P3 is loaded into CPU and burst time of P3 is 8. So it will be executed up to 11. Okay. Now P3 is completed. Now at time t equal to 11, how many process left? P4 and P5 are left. Which one is having highest priority? P5. So P5 will be loaded into CPU. What is the burst time of P5? 5. So 11 plus 5, 16. Then P5 is also completed. The only process that is left is P4. So there is only one process. That process will be taken into CPU. Then burst time of P4 is 4. So it will be executed up to 20. Now look at the order. It is P2, P1, P3, P4, sorry, P5 and P4. The completion times of P2 equal to 1, 3, 11, 16, 20. Okay. Now write down these completion times. P1 completion time 3, then P2 1, P3 11, P4 20, P5 60. Okay. So now calculate the turnaround time CT minus AT, completion time minus arrival time. You will get 3 minus 1 2, then 1 minus 0 1 and 8 and 19 and it will be 14. 16 minus 2 14. Then you can write the waiting times. What is the formula for waiting times? Turnaround time minus burst time, CPU burst time. So it will be 2 minus 2 0, again 1 minus 1 0, again 8 minus 8 0, again 19 minus 4 it will be 15, then 14 minus 5 9. So finally you will get this value. Okay, I'm already written this value. Okay, so you will get 2 plus 1 8 19 14, you will get 44 divided by 5, that is 8.8. Then this will be 24 divided by 5, that is 4.8. Okay, so this is priority scheduling, non-preemptive priority scheduling.